So I'll explain it again to you. So we were dealing with the make list command when we started working on the discrete plots where you will be plotting some random points. So it's not always easy to give the list. Okay, so if you need a list of some 100 points or 1,000 points, it's not easy for us to always give the list exactly like manually, right? So for that purpose, if you wanted to have a iteration value, or if you wanted to have some thousand or how many ever points you need, okay, you can always use the make list command for that. So what does the make list actually does? So you give the function, okay, in the function which you wanted to plot, okay, and the n is a variable in which the function defined, and this minus 10, 20, 0.2. What does that set of values does is it will start the value of n from -10, okay, and what they are going to do is they're going to take a step length of 0.2. So step length of 0.2 means after -10 they will add a 0.2 to make the n the value of n. Okay, so it will be like -10. We start from n equal to -10, then we add 0.2 to get the next n till we reach n equal to 20. We continue this process. So you will be getting a set of n values, and what the make list do is when we are getting the n values, set of n values, you will be correspondingly getting the value of your sine of n over n. Okay, so you will be starting with n is equal to -10. So you will be getting a list of sine values basically. Okay, so what we are doing here, so when uh, we are calling out s is equal to make list of the function comma the variable and the range of values of n with the step length. So I can show you like if I share the screen, can you this screen the another screen class? Okay, fine. Second. Can you see them now? Class, are you able to see them now? Okay. So there you can see here when I give or when I executed this particular function, that is s is equal to make list of the sign. What is happening? It's giving you all the range of values in between -10 and 20 with all the sign values, right, starting from sign of 10 comma 10. Okay, then it will be giving you all the values. Because so are you able to understand? So basically it will be giving you a set of values of the function. So rather than typing the set of variables, set of values, we can use the make list command always to make a list. Okay, is that clear to you class now, the functioning of make list? Maybe it is with my maxima. You can just try with your values also. Okay, in your maxima you may be able to see the float value. Yes. It's not like to execute a trig function. It's just to get the value. You can, instead of the sign n over n, you can use any other function. Let's say n to the power 2. If you wanted values of the list of the type, okay, 2 square, 2 square, 2 to the power 3, 2 to the power 4, you can always write in the form like 2 to the power n, where the n value varies from say 1 to 100 with a step length of 1. So you will be getting the set of 2 to the power n values. So it's not just with the trigonometry functions. You can use the make list command for any type of function. It's just to create the list. So it's not easy for us to type all these, right? Type all these set of values. Correct. In the previous question, we were trying to list the set of coordinates, and then we were plotting the discrete points. Correct. But it's not always easy for us to type all the values which we require. So it's always advisable to use the make list command where it has where the values has a common nature, like they have a common function. So in that case, you can always use the make list command. Okay. Yeah. So shall we move to the next one? Okay. Maybe we cannot identify actually the real problem because that appears to be sign of 10 over 10. That's what we can say. That's it. You can plot a line. So line will be the function what x. Correct. Make list of, you give x comma, okay, the x comma x comma. So first you will be writing the function. So since it is a line, you can, so if you wanted to have the line with the different slopes, suppose, okay, say y equal to mx. Okay, that is how you usually generally write the equation of a line. Okay, yeah, this is the codes. That's it. This is the code. Make list of the function, the variable, the minimum value of the n, okay, the maximum value followed by, and the step length. Okay, yeah. So that's how. Even in my maxima, it appears. I mean, like in yours, everywhere it's appearing the same sign of 10 over 10. So I'm really not able to find the reasonable answer for that. Basically, if you get to the answer for that particular question, why is appearing it's like sign 10 over 10, you can always share in the class. Vipu. Okay. Yeah. So we know that it's yeah. Repeat about the make list command, Hitesh. Okay. Nothing, like we use the command. See, this s is basically the variable which store this list. That's it. Okay, instead of writing, see here you can see I have written a equal to the list. So instead of writing it manually, okay, instead of writing it manually, what I could do is, so here I am writing list of list. So you can see here a bracket, a square bracket, right? One square bracket, and inside the square bracket I have having two lists. So this gives you the set of x coordinates and the y coordinate value, whichever you wanted to take. So here I have assigned a variable where it stores the list basically. So here also I'm storing the set of list. Okay, the set of, see here you can see the bracket, opening a square bracket, and the closing square bracket also you can see over here. So these many set of values I can't enter manually. So what I'm doing is using the make list command. I'm just creating the list of values by taking the values of n, okay, taking the values of the variable of the function ranging from minus 10 to 20 with the difference of 0.2. So it will be starting from n equal to negative 10, then negative 10 plus 0.2. That will be the next value of n. Okay. You can always just recheck in your calculator, like, is it doing the same thing? Okay. Is that clear, Ritesh, now? Okay. So that's how the make list command work. Is that clear with you, class? Can we move into the next topic? Class, please respond in the chat box. Is it clear? Okay. So now we'll move on to the different conditional structures. You might have come across the. One second, I'll share the screen. Class, can you see the screen? Yes, okay. So now we're going to learn about some conditional structures. So if you have done your C, like your C and C++ in your like +1 or +2 or like PU colleges, you might have come across different conditional structures like if, for, while, loop, and all. Correct. So here, in order to suit our basic at the top, I mean, like the subject we are learning over here in Maxima is the differential calculus using Maxima, right? So when we come across the differential calculus, we need to know how to go about the limits, okay? Uh, how to go about the limits, or how to go about the continuity of a function or differentiability of a function. Okay. So we all have learned like what is the limit definition, what is the like continuity definition, how will you check whether a function limit of a function exists or not. Okay, so many things are there around it, so we'll be discussing all that in here. So in order to understand in a deeper way, we are using some conditional structures inside it. Okay, so I'll be explaining here the if condition and the for loop condition. Okay, so it's just a basic. If you have learned the C and C++, it's very easy for you to understand how it works. Okay, so but I'll be explaining for those who don't have any background of the programming thing. Okay, so let's start from a set of text which I have written. Yeah, it's more like a Python only. Like every programming language has a conditional structure. Okay, every programming language. So even if it's in Python or in MATLAB or in any kind of thing, you will have a conditional structure for sure. Mostly they will be having the kind of the same command and same working. Okay, only the syntax will be a little changing, depends upon the ending. Like sometimes it ends with a semicolon, sometimes it ends with a colon, something like that. Okay, yes, so here the conditional, so the first thing, a conditional or the branching, okay, controls the execution of a program based on some conditions. Okay, so we can always say that uh, if I wanted to execute something, say if I wanted to print the expression one, okay, if I wanted to print say hello, okay, I'll be putting some condition over here. Okay, if some x is equal to 2, okay, I'll be assigning some value for x. Okay, and I'm going to check whether that particular condition is satisfied or not. Okay, this condition can be any inequality. Okay, like any, it can involve any logical and relational operators. Okay, the conditions, it can be an equal to assignment function, or it, I mean like equal to checking both left and right, or it can be greater than, or it can be less than. So those kind of logical operators you can use. Okay, or and using the and, all of them you can use over here. So basically the conditional structures, okay, the program works on the condition. Okay, if the condition is true, it will print a set of commands which is inside this if loop. Okay, if not loop, if. Okay, then if this particular condition is not correct, what happens, it will not, the programming or the Maxima will not going into the command, okay, or inside the set of commands of if. Rather than that, what they will be doing is, if immediately if it finds the condition is false, it will be going to the else. Okay, it will not be going inside the if. What they do is, it will come directly to the else, and it will be printing whatever set of commands are there inside the else command. So the this expression one works if the condition is true, and expression 2 works if the condition given is false. Okay, so this is the one type of conditional structure, that is if else. Okay, another one is your if you have a set of another, like if you wanted to include more conditions. Okay, say if x equal to 2, you need to work the expression 1, and if x is equal to say 3, you need to work this expression. Okay, if that is the case, if you wanted to include more conditions inside the program, then you can always go for the command if. Okay, else if how much ever conditions you wanted to include, that many else if commands you can include inside the if. Okay, and the last command, okay, the last expression, that is this expression, works when all these commands, okay, are false. Okay, only if all these commands are false, this expression will work. If any of these condition is becoming true, it will go immediately inside the else if and to work the command inside or the print the command inside. Okay, so this is the basic syntax of a if else, okay, structure, if else conditional structure. So let's see how it works for a program. So here you can see that what I'm doing here is write a program to find, the first question is like write a program to find the greatest among the 5 and 7. So what you need to, it's a very simple program. So what you need to do is you are assigning two variables with values, say a equal to 5 and b equal to 7. Now what you're trying to do, we need to check whether 5 is greater than 7 or like that. Okay, we need to check which is the greatest among them. So what we are going to do here is we are working on the condition. So if a is greater than b, so what does that mean? Here a is already having the value stored as 5 and b is already having the value stored as 7. So if this statement is going to work, like when the maxima read through this line, what is happening? The right now the a and b are say 5 and 7. So what is it reading like? If 5 greater than 7, is that condition true, class? 5 greater than 7? No. So that condition is not true. So what happens? It will not go inside this. If what else it do? It comes to the else immediately. It will not go inside the if. So the print command which is written inside the if will not be working. Rather than it will be printing what the command which is inside the else. Okay. So yes, prints the else statement. So print what happens. So here whatever we need to print, that command, that set of line will be written inside the double quotes. Okay, and if you're not writing a and b in double quotes, what does that mean? It is the variable a and variable b, so it is already having a value stored inside it, so that will be written as 5. Okay, 5 now is smaller than, that is the printed thing that we need. Okay, b is taking the value 7, so it shows you 5 is smaller than 7. Okay, yeah. If you don't want 5 and 7 to come up in, you can always suppress it by using the dollar sign. Okay, so let's say here, see, now when you apply give the dollar sign, it's not showing up any 5 or 7. It's just directly give you the answer. Why there is a comma? Because you have to separate the variable and the printing command between them. Okay, so you need to write the comma in between. Otherwise, it will give you error either, or it will not be executed. Here, the indentation is not an issue actually. In the case of the Python, you can always see that the indentation is a very big problem. If the indentation is, if the spacing is not correct, then it will not work. But in the case of the this particular maxima, indentation is not a very big deal. Okay, you can always, yeah. What is the syntax error is showing? If you're not writing the comma, right, Pallavi? Yes. So it will be because that is not the way of writing the thing. So if you are writing all of this A and B inside the double quotes, you will be getting like A is smaller than B. Exactly, they will be printing the variable A and B. They will not be printing the value. So when it's not inside the quotes, it's basically taking the value stored inside the variable. Okay, is that clear, class, the program? Yes. So now we'll see the next question. So here we can see that we have initialized the value. Okay, we store the value and we are working on the program. Now, if a person who comes out of your area, okay, is wanted to work on the program which you have done, we always need a user-defined programming. Correct. So user-defined programming means any user comes, that person should be able to input to the values whichever whatever he or she needs, right? So in that case, the user defining is very important in any kind of programming language. So here you can also read the values from the user by using the command read. Okay, so the next program, it's the same program, but you need to enter the two distinct numbers. Okay, you are asked to enter the numbers and you should be finding the greatest number. If you are writing the program, it's fine. You can give the values initially, only you can initiate the values and write the program. But if a person comes from outside, just need to use the program, then that person should be free to use any values. Correct. So in that case, you should have a very user defined program. So that case, you can use the command read, where it will be reading the values, whatever values you wanted to give, that you can be entered. So if I work this program, you can see that immediately it is giving enter a number. So this happens when it is reading the first statement of the program, okay, or first line. So A is another variable which will be storing the value, or which it gets through reading the first line. Okay, so enter a number, I give say 12. Okay, now I have to do what? Shift enter. I should not be doing the ender. Ender will not work because the this is the maximum program. Whenever you wanted to execute something, you have to go for the shift plus enter. Okay, so then you can use the then it will be reading through the next line of the program, which is what? B is equal to read enter the another number. So you will be entering the another number. So it's not necessary that you should give something inside the read. Okay, if you wanted to display something for the user to understand, okay, then you can give the statement inside it. Okay, even if you don't write this enter a number, then also it will work, but the user will not understand the maxim is asking you for some value. Okay, so that will create a misunderstanding or a communication gap between the program and the user. Okay, so it's always advisable you give some some statement inside to print out, so that the user will be understanding how to go about the program. Okay, so once I give the another value, what happens here? It just does the same program. Ma'am, is the greater than or less than already defined in the software? Yes, yes, it's already defined. So these are the logical operators, it's already defined. That's why it's working. Otherwise, it will be showing a syntax error. Okay, so here it's working on if, so there are many other logical operators. It's not just less than or greater. You can always not equal to. There are so many things. You can just explore all of them by yourself. Okay, we wanted to basically do the limits. For that only we are just going over the condition structures. Okay, so here then everything will be working the same as we did before. Now it got the value A as 12 and the B as 13 according to the user wish. Okay, now it's stored the value. Now it will be working according to the if else command. Okay, is that clear, class? The second program where the user can define the values. Yes. So now let's see the third program. So what is it asking for? Write a program to enter the distinct numbers and check whether the two numbers are co-prime. Okay, so co-prime, you can always give the conditions according to you. It should work the program. That's it. So how will you usually check the co-prime thing? So GCD and all, it's all defined. You can see that the very basic kind of things like LCM, GCD, all of this will be defined in the program itself. So we just have to use it, right? So you know that you can say that two numbers are co-prime to each other, okay, when they have the GCD, that is the greatest common divisor, is equal to 1. Okay, say if you take 3 and 5, we know that there is no common thing that between them. So it is equal to 1. There is no greatest common divisor. It is 1. So if it's equal to 1, then we can say that 2 and 3 are the co-prime to each other. But if we take some numbers which are having some common devices shared between them, say like 2 and 12 or 2 and 24, you can immediately see that you will be having a greatest common divisor is 2, which is not equal to 1. So in that case, what happens? We can see that it is not co-prime to each other. Okay, yeah. So you can always check the numbers of your choice. It's up to you. But the program is basically, again, we are user defining the variables A and B. We are reading the values through the command read. Then we are checking on whether the GCD of A and B. So right now we have already given the value of A and B. Okay, now it checks GCD of, say here I have given A equal to 4 and B equal to 8. So I can see GCD of 4 comma 8, which is equal to what, basically 4. So you can see that it is not equal to 1, so which means it will not go into the if statement. Okay, so what else it do? It just go into the else statement, which it prints 4 and 8 are not co-prime. Okay, so you can see always here everything is separated between by commas. Okay, that's how the syntax is. Whenever you wanted to separate the variable and the printed command, you always have to make sure that you're putting them in the double quotes and separated between the commas. Is that clear, class? Ritam, what is the problem? Ma'am, it's not coming for previous function. Previous function? No, we need not to. How, what is the here, what is the if else if you're asking me? Yeah, we need to use the else then condition. Yes, only for the else we don't have then. Till that you have to use the syntax like else if then condition then. Yes, see, dollar sign is basically to suppress the some values. Okay, so when you wanted to print, you can always see if you remove the dollar sign, it will be printing something else. It will be printing mostly the last value. So it's better always you give the dollar sign. Okay, at every end of the if else command, if else condition. So I need not ask you to give it the dollar sign at the print command of the if, but I always ask you to write the dollar sign at the end of else. Okay, otherwise it will not be giving you the proper value. Yeah. Okay, you can just check by yourself. You can verify yourself what happens if the dollar sign is removed or if I put the semicolon. You can always work on all of that. Okay, so is that clear, class? This much about the if condition, if else if condition and all, and the command read. Can we move to the next one? Class, please respond. Mm-hmm. Okay. So now we'll move into the another condition structure or looping structure, which is for loop, which is also very familiar with the C and C++ programming. Okay. Cofactor, co-prime. It's just this. We are using the condition GCD of A B equal to 1. That's it. If it is true, then it will be going printing this set of command, this command. You can always, it's not necessary that you should only have this particular only one print statement, not necessarily. You can have any set of print statement. You can also give another print statement inside, okay, whatever you wanted to. But the thing is, the condition should be working over there, then only it will be showing the command inside it. Okay, say if I give say true and close it, and if I work this, it's giving 1. So let's give another one. Say 3 and the 7. Oh, no, 1 second. I'll just run it again. 3, 7. Okay, it's showing print is not an infix operator. Mhm. We need to use a semicolon. Okay, it's still showing. Fine. I'll just come back to that later. I don't know why it's not working now. 7. Okay, so here now we have the for loop. Okay, so for loop, how does it basically works? Okay, it just got wrong. I don't know, this somewhere went. Okay, okay, fine. So let's move into the for loop now. So the how the yeah, loop, you got the answer. Very good, Ritam. Yeah. So here, how is it working basically? Uh, so in the case of for I equal to 1, so what is happening here? The syntax is basically for. Okay, now you have a iterating value. Iterating value here is your I. So usually in the C++, you can see that the command will be like, uh, so usually in C++, you will be seeing like for I is equal to 1, right? Uh, right, 1 to something. So that's how you will be giving. So instead of equal to, what you can see over here is the basically you can see here is what the through command. Okay, so no, equal to, instead of it, we know that any variable which assigns a value will be giving the colon sign. Okay, so for I equal to 1 through 10. Okay, so which means what? I will be taking the value 1 first. Okay, then immediately. So the first time I iterated the loop, I go through the loop, I equal to 1. So it immediately comes into the set of statements inside the for. So here print I. I is what here 1 right now. So 1 and 1 plus 2. 1 plus 1, which gives you 1 comma 2. 1 and 2. Okay, now what happens? The I will be next will be added uh, with a 1, right? So I equal to, initially it was I equal to 1. Now after running through the print command once, it will be iterated to, or 2 basically. Okay, so right now this in the second line it will be I equal to 2. Now it comes into the print statement. So right now I equal to 2, so 2 comma 2 plus 1, which gives you 2 comma 2 and 3. Okay, then the I will be updated to 3. Okay, it comes into the print statements 3 comma 3 plus 1, which gives you 3 comma 4. Okay, yes, Rishikesh. Yeah, which code you want me to try? Oh, instead of print of I, You wanted to write it as A. So if you're writing it as A, see, what is your stored value of A? That will be coming out. See, you know that previously I have given A is equal to 3, right? That was my last value which I give. So here I give A equal to 3. So already the maxima will be having A needs to be accepted because A is already, see, we haven't done the killing option thing. If you did the kill done, then the A will not be having any value. But right inside the previous program, we know that A is already stored as some 3. If you were using some other variable C, which says C, it will not be then, it will be showing what C instead of the value. Okay, since we have written as A already we have stored a value inside it, which is 3. So that is why it's showing the same thing 3. Are you able to understand, Rishikesh? Yeah. So what is the doubt, John? Can't we print the output in one line? Can't we print the output in one line? So that is also possible. You can just go over it. There are so many spacing commands. There are so like to print on one line, that is commands. Okay, you can just explore yourself on that. Okay, we are not going that deep into the programming thing. Hmm? Yeah. So is this four condition is clear to you? It's just iterates the value of I, and it prints whatever. It's not necessary that you need to write the I plus one. Okay, you can see, you can just print the A. If you wanted to print A some 10 times, you can use this for loop. So I equal to 1, it just get into the print command, it will be printed. Say like if I execute this one, so you can see the 3 is executed how many times? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 times you can see the command being printed. Okay, so it's just iterates the, it will be revisiting the statement inside of the for as many times the I is walking through a particular value. Is that clear, the class, the for loop thing? Okay, so now we'll move into the evaluation of the limits. So can you tell me, what do you know about the limit of a function? How will you find the limit of a function? What are the different types of limit that you have learned? So just answer with this one. What are the different types of limit that you have learned? Left hand side limit and the right hand side limit. Okay, good. Is there any other answer from class other than left hand side limit and the right hand side limit? Limit approaching the infinity. So, mm, okay, John. Yeah. So, basically, if you ask for the different types of limits, it's just left hand side limit and the right hand side limit. But uh, it's as we go for the different types of functions, you can say like trigonometric limits of trigonometric functions, limits of polynomial functions, all of that. Okay, that is fine. Mhm. Okay, so that is also fine in the case. So then, in the case of the limits, we know that it has got the left hand side limit and the right hand side limit. So why we are basically checking both the left hand side and the right hand side limit? Can you tell me when we say the limit exists, class? When the right hand side limit and the, yes, exactly. So when the right hand side limit is equal to the left hand side limit, we can say that the limit exists at that point. And we also know that within the limit definition only we define the continuity, and therefore thereby we define the differentiability of a function also. Correct. We are going to check. Okay. So we in while doing the limit thing, okay, we can see sometimes the left hand side and right hand side limit may not be true. I mean, like same, or you can see situation where the when you plug in the value of the x inside the polynomial functions or the rational functions, sometimes you can always see it is an undefined form, that is either 0 over 0 form or infinity over infinity form. Okay, so you might have learned all of those situations where you deal with the undefined forms. Okay, you will have a particular method to do that. Correct. L'Hospital's rule, there are so many, yeah, indeterminate forms basically. Yeah, exactly, answer. So, so here what we're going to start with is, let's see how the, it's very simple in the maxima. It's very simply defined the command for the limits. Okay. So before going into that, we can always use the for loop to actually check. Okay. So before learning the different methods to find the limits of polynomial functions and the trigonometric functions, the first type of thing that we have done is just manually giving the values of x. Okay, we're closer to the x values at which the limit has to be found. Okay, from the left hand side and the right hand side, that's what we usually do, right? So basically, I'll share my another screen. 1 second, yes. Yes. Okay. Class, can you see the screen? Yeah. So if I want to, if I have a function, say y equal to, okay, y equal to x squared. Okay, if this is my function, and I wanted to find the limit of this particular function, let's say x is equal to 2. So what I should do is basically here is I'll be approaching. So we know that y equal to x squared is a parabola, right? Which has got a vertex at the origin, right? So this is how it's looked like, and it has got an axis of symmetry as your x-axis. I mean, like y-axis and all. Okay. So if I wanted to see where the function is, so what actually the limit says is, as the x value from the left and right side. So if I suppose say give x is equal to 2, so it will be somewhere here on the x-axis, right? So I just wanted to see, as I give the values of x from the left hand side, okay, and or if I say if the values of the x is approaching to 2 from the left hand side, and if I'm approaching from the right hand side, how the your f of x is behaving like, or y is behaving like. So what I'll be doing from the left hand side means I can just take closer values, very closer to the 2, right? 1.9, 1.99, and just see how the function is behaving like. Okay, so my function is x to the power 2. So if I suppose if I plugging in 1.9, I'll be getting what? Say 3 point. Can you tell me if I plug in 1.9 in x squared, what is the value we are getting? Plus, can someone tell me? 3.61. Now, if I give 1.99, can you tell me what is the value then? 3.96. Is it when you plug in the value of 1.9 in? Yeah. So 3.96. Now, if suppose if you're giving 1 point, say 1.999, okay, then what is the value of your y? 3.9996. So what is happening as the x value is approaching to the value 2, your f of x or your y is approaching to the value what 4 basically, right? So this is what we are checking from the left hand side basically, right? And we need to check from the right hand side also in the similar way. So we can start from a very far value, like say we can start from 2.1, then decreasing say 2.01, now 2.001. So what we are doing is we are approaching the x, okay, we are approaching to 2 from the right hand side, okay, as x is tending to 2 from the right hand side. Then also you can see that the function will be approaching to the value 4, right? So basically this here and all you can always see that the left hand side and the right hand side limit are equal, therefore your limit exists for this particular function at x equal to 2, correct? So this is what we are gonna do. Mm, that yeah, this is the manual process, that how will you check the limit of a function at a particular point. So we are going to do this or execute this particular thing using the maxima, with the help of the for loop function. Okay, so let's see how that is working now. So with that we'll wind up just here. mm, okay, so can you see over here my uh, class, can you see the screen? Yes. So here, what did we have started with? We'll just start with this particular one, okay, where I'll be explaining that a little later. So I wanted to find the limit of the function f of x is equal to x squared minus 4 over x minus 2 at x equal to 2. Okay. So what I did, I first defined the function. We know how to define a function with the colon and the equal to sign. We assign the function. Now, in this is just for a beautification of the output. We just wanted to recognize which is x and which is f of x. So for that particular thing, we are giving the statement, say print of that particular thing. Okay, it's not necessarily you should give. Okay, it's according to you. Now we are working on the for loop. So what is the for loop is doing? For I equal to 1 through 10. Okay, so right now for the first iteration I is equal to 1. Okay, now what happens? The maximum will go inside the set of statements. So here you can see that it is ma'am, go the limits. Yeah, no problem with it. So here the function is what? Here we are defining, this is a I am defining fun, which is a variable basically. Okay, I am defining the variable with the values as what? 2 minus 1 over 10 to the power of I. So in the first case I equal to 1, right? So which means 2 minus 1 over 10, which means what? 2 minus 0.1, that's happening. So this variable is storing the value, say 1.9 for the first time. Okay, then what they are doing, now we are defining another variable. Okay, we need the float value, that's why we are defining the data type of the variable over here. Okay, so that it will be taking and giving the output in that way. Now we are defining another variable, say f, okay, with float of f of function. So right now, what is the fun? Fun is 1.9. Now, what is our function over here? This is your function. So f of 1.9 is what we are doing. So what does it do? 1.9 to the power 2 minus 4 over 1.9 is 2. And what we are doing? We are printing the function, which is the value of the x. Okay. And in order to give some space in between, we are just putting the double quotes with a space in between, comma f. F is what the value of the function at that particular value. Okay, so we are getting the first value is 1.9 at x equal to 1.9. We are getting f of x equal to 3.899 for the function. Now, what we need, we are checking with a little more closer. So you can see that we are approaching from the left hand side over here. When I'm doing 2.2 minus 1 over 10. Okay, now I is updated to 2, which I get 2 minus 1 over 10 to the power 2, which means what? 2 minus 1 over 100, that is 2 minus 0.01. So, which means it is 1.99. Okay, so similarly, this value, these all values are from the left side of the value 2. So this particular thing is basically approaching from the left hand side of the x. Okay, so this is your, you can see that as the x is approaching from the left and getting more and more closer to the 2, hmm, your f of x is approaching more and more closer to the value 4. Okay, so this is how you can understand from the like for loop thing, what is the limit, okay, from the left hand side. So this can be executed using the limit command in the maxima, which is limit. We give the function, okay, we give the variable in which the function is defined. Now we give the value of the variable at which we need to find the limit, and we are specifying which type of limit we need. Left hand side, if it's left hand side, we use a minus, and if it's right hand side, we use the plus. Is that clear, class? Is this much clear to you? Class, please respond in the chat box. Are you, yes. So similarly, yes, got the limits. Okay. So because it's already 3 now, we need to put you assignments and all. Okay, so you won't be getting enough time. We can discuss this in the next class anyways. So I believe at least some of them understood what is the why we are using the for loop here to understand the limit definition. Yes. Okay. So if you have no other questions, then you can leave the session. Okay.